So hello, everybody. My name's Kevin Huck. I am fairly recently at AMD. You probably know me from University of Oregon. But I've been with AMD since middle of last year, about April of last year. And today I'm going to talk about building ROCm with Spack, and more importantly, what to expect with the ROC, which is a reorganization of all of the ROCm GitHub repositories. And I should point out that most of the package management happens from the other four co-authors on the talk, and then they really helped me put together the slides. So what is ROCm, for those of you who don't know? ROCm is an open source stack of software that's designed for graphics processing unit computation, GPU computation. It's all the drivers, the development tools, APIs that enable GPU programming from kernels all the way to end user applications. It's powered by HIP. You're probably familiar with HIP, a C++ GPU programming environment, and its runtime. It supports a couple of different programming models in addition to HIP, OpenMP, target offload, as well as OpenCL, and also open source compilers. The compiler, for example, is LLVM based, and debuggers and libraries. So the debugger is GDB based, and then other open source libraries. And it's fully integrated into machine learning frameworks, including PyTorch and TensorFlow, and it has full Triton support for everybody who's interested in that. So let's talk about the motivation for the ROC. ROCm has grown significantly since 2016. The single monolithic binary release was too large. So if you wanted to install ROCm, you got everything. You got every architecture support, you got all the solver libraries, you got everything. And it was a lot to install for a lot of users. And for those who were trying to build it themselves, it was kind of complex and error-prone to pull packages from multiple locations and build them and test them from source. It's a combination of bash scripts, it was a combination of CMake and make files, and this is also true when trying to build the binaries for release. In some cases, it required manual intervention for some of the CMake build flags. And most importantly, coordinating changes and PRs across different repositories was difficult. And you can imagine if you're trying to merge in a change from one repository that requires a certain version from another repository, and none of it's coordinated in any automated way, it's very difficult. So if you want more information on the blog post explaining why the ROC happened and the FAQ related to it, there's a couple links there. So what is the ROC's approach? The ROC's approach is that it's managing dependencies between packages automatically, and dependencies with respect to PR changes and things like that. And it coordinates the changes that affect multiple ROCm components. It's a pure CMake build system, and it streamlines the propagation of CMake build flags and configurations. And also, very importantly, you can do incremental building with it, and you can do build caches, not build caches, but cached builds locally using Ninja, and it builds significantly faster. There's also some integration of Python for dependency management for installing Python-related packages. And what's really been good for us internally is that it helps manage a single build testing and CI pipeline. We now have nightly builds that are available for users. If you go to the ROC, you can actually access the previous night's build of the entire full stack for a specific architecture and test it. So you don't necessarily have to build it yourself, but you still can. And we have cross-project CI testing now, so when a change to one solver library that might have an effect on another solver library happens, we know about it a lot sooner than we used to. And it also really integrates multi-platform support better. So we have an Anylytics release now, so the builds will theoretically install on any version, any distribution of Linux, and Windows support. So the strategic reorganization of ROCm into the ROC is basically we have the ROCm Core SDK, which is essential components for AI workloads. So it's the ROCm, well, we'll get into the details in a bit. And then we also have some market-specific expansion packs. So for HPC, for example, there will be a separate expansion pack. I'm not quite sure what's going to go into that. That's sort of TBD. But you have ROCm Data Science, which includes a number of different libraries that are useful for data science, and then a ROCm Life Science package as well. And this is not yet supported in Stack, but I can certainly see a good motivation for doing this. That if you had a meta package or something like that where you could combine these different components of ROCm and say you want to say Spack install ROCm HPC, you'd get what you needed. And the timeline for this is that all these changes are expected by mid-2026. So thinking about the software stack that powers AMD, we're really talking about as far as the ROC is concerned, the ROCm core and the expansion SDKs. So the ROCm core includes the runtime and compilers, the storage, SMI, the monitoring interfaces, as well as math and compute and communication libraries like RCL, and support libraries like the profiling and debugging tools. So diving a little bit more into the core SDK, what exactly is that? We have let's see, if I had a laser pointer here. So we can, laser pointer. We can look at you got the core, the runtime, as well as communication libraries, so we have RCL and so forth, all the math and compute libraries, so the different solver libraries, and profiling and debugging, and as I mentioned before, ROCm SMI and AMD SMI. One thing that, if you're not familiar, ROCm SMI is being deprecated away. A lot of its functionality has been absorbed into AMD SMI, and so if you're developing new products or wanting to, or if you currently use ROCm SMI, you should probably be transitioning to AMD SMI. So you're probably saying, great, that's all the changes for the ROC, and so this is a Spack presentation. So how does this relevant to Spack? Well, the Spack packages for ROCm are going to get a minor set of changes, but otherwise the user experience should more or less be the same. Starting with the release 7.2, so it's already out and already merged into Spack, into the Spack develop, the source is going to be pulled from new repositories or new tar file locations. So if you're doing development build or pulling releases, it's going to pull from the new location, and the older versions will remain unchanged. So if you're wanting to build ROCm 7.1, it's still going to pull from the older repository that have been deprecated, but as far as I know, they won't go away until they get end of life. So all the Git-based builds will also be changing to the new repository locations. Paths, there's a few little minor tweaks here and there for inside some of the packages that some directory structures have changed. So that just changes how some of the patches might be applied and things like that. But an important thing to emphasize is that the Spack user experience should be unchanged. And if you see different, please let us know. So I'm going to jump back and talk about the ROC again and say, the ROC itself is an aggregated super repo of 3 mono repos. Now that's a little bit contradictory, but these are the 3 main repositories that are aggregating the different components of the ROC. When I went to install it with Spack, what I found was the first thing to do was to install the LOVM project, which is basically a fork of LOVM plus all of the modifications necessary for building and running on AMD hardware. And then you have the ROCm systems components, which are the SMI libraries I mentioned before, HIP and ROCm info, the compute library, SDKs, and profilers and so forth, profilers and tracers. And then finally, you've got all the ROCm libraries that you might not necessarily need, but if you're doing something with PyTorch or if you're wanting to use the HIP BLAS libraries, then obviously you're going to need these components. And I don't know what the actual strategy is going to be for these things, but I think these are natural fits for meta packages where you could build these and have each of these be variants that are by default enabled, and then you could Spack install ROCm systems minus some piece that you may not need, like the profiling tools. So this is a little faster because I thought I had 10 minutes, not 15. But if you have any other questions, please ask me. I'm easy to find, kevin.huck@amd.com. And if you have any questions about the Spack packages, you can definitely contact the Spack package maintainers. Their names and email addresses are here. They're also included inside of the various Spack packages themselves. And then the usual legal stuff. So if there's any questions, I'm going to jump back to the contact slide. You, sir, in the front. Who has the microphone? This one? Yes. You got abandoned.
Yeah, so with the new structure, is it just pulling the same rock download for all of the different components of Spack builds, and then just pulling the source out of that in one download?
I don't know. I haven't looked at the guts of it, but you can do a sparse checkout of the different components.
Yeah. Okay. All right, that makes sense.
Yeah. So
Yeah,
whether it's doing a sparse checkout, I don't know exactly, but it's possible. But yeah, I mean that would be one of my concerns too. Is that if you want to build one package, are you downloading the entire monorepo?
Right.
Yeah.
You can do that in Spack. You can do this.
Yeah. Yeah. I know you can do it. Whether the package leverages that, I don't know. Yeah.
Cool. That's all I got.
All right. Oh.
Yeah.
You read the legal slide really quickly?
Thanks, Kevin. I'll ask a fairly naive question. I find that sometimes one of the pain points is getting ROCm installed correctly on a system I want to build for, or an image, a Docker image or something, or just setting up Spack to load what's on the system. Say for the sake of argument, I'm a lazy person. Mm-hmm. Could I just ignore all of that under Spack and just build my packages with the plus ROCm?
I can even save you a step and say just install the Docker images that have ROCm pre-installed or PyTorch pre-installed or things like that, if that's really where you want to start. So the longer answer is, if you do want to build it and install it yourself, there are documentation pages on the ROC for how to build the ROC with Spack. I will also say that it's currently out of date, and I've submitted an internal ticket to get it fixed, because when I was walking through the steps to test things for these slides, I found a couple things that were out of date with respect to Spack-specific things.
Okay, so lazy person, probably not the best strategy to just download, to get Spack and say install.
Correct.
It's gonna build a lot of stuff.
Well, sure.
Yeah, but I mean,
I might be lazy and patient.
Yeah, but you say that, but with some of the new parallel builds strategies that are in Spack, I actually found that to be really useful. Setting up parallel builds as well as concurrent builds.
I'm pretty psyched about that for buildings.
Yes.
Because I think people get sick of waiting for all that right now.
Yeah, I mean the LLVM package is obviously the one that takes the longest to build. So get that one first and out of the way while you're doing all the other stuff.
So I think at the moment, I don't know that the ROCm packages support detection. So we have
Detection
so you can do Spack external find.
Yes.
It would be extremely nice if the AMD folks could maintain detection logic for this stuff, so that basically you can get your external set up properly in one command if you happen to operate in the images. So, but we could work with you guys on that. Just saying.
Yeah, no, just make the request. We'll see. We'll get it done.
Okay. All right, let's thank Kevin one more time.
Thanks.